topic, which is related to the design of gravity retaining walls. So we will briefly touch on the types of retaining walls. Then we will move towards the design of gravity retaining walls. Then we will discuss the choice of backfill material and the drainage systems for different backfill materials. So starting with the types of retaining walls, we can see that there are gravity retaining walls, sheet pile walls, cantilever walls, and the anchored walls. Now, the gravity retaining walls, these walls are the earliest retaining structures. They were massive gravity walls and they were made of mortared stones or masonry or reinforced concrete, and they will resist the lateral forces from the backfill. So if the lateral or horizontal forces are applied onto the retaining wall, so this retaining wall will resist those lateral forces. These are kind of uneconomical. This construction of these walls is very labor intensive and requires large quantities of materials. So they are rarely used today except for very short walls. Sheet pile walls are also constructed to retain the soil, and the cantilever wall just to reduce the amount of concrete or the stone masonry used and to utilize the weight of the soil, backfill soil. So the cantilever walls were also constructed to resist the lateral forces which are applied onto these structures. In anchored walls, an anchor is provided to just give an added support to the sheet pile wall or the retaining wall here. So different anchors are provided just to give that extra strength to the retaining wall. Now our focus in today's lecture would be on the gravity retaining walls, and basically the gravity retaining walls, the stability of the gravity retaining wall is dependent upon the self weight of the wall, because the weight of these retaining wall is huge. Therefore, if the lateral forces are applied onto this retaining wall, that is resisted by the weight of the material which is made of this retaining wall. Now, there is also a passive resistance which is resisting the lateral forces which is acting from the left hand side of the retaining wall. So we also discussed in GeoTech 2 a little bit about the active lateral earth pressure and passive lateral earth pressure and at rest lateral earth pressure. Now our focus in this class will be on the design of the retaining walls. Now, these are the gravity retaining walls, and then in order to reduce the amount of concrete or stone masonry used, some people call them semi-gravity retaining walls. So these are also called reinforced concrete retaining walls. You might have seen in villages, along the streams, along the slopes, the gabion walls. So these are kind of cages of steel mesh and rectangular in plan and elevation filled with particles, generally cobble size. So these are known as the gabion walls. So these are also type of the gravity walls. There is another type which is a crib wall, and in these cribs these are kind of an open structure, so you can clearly see it's kind of an open structure which are assembled from precast concrete or timber. Members are also used, and they enclose granular materials, and they act as a composite unit to form a gravity retaining wall. So the purpose is to retain the lateral forces which are acted by the backfill material. Now, if we see the cross sections of the different types of gravity retaining walls, so you can clearly see that the weight would be acting downwards, and horizontally those forces would be acting in the horizontal direction, that P, due to the backfill material. This portion is known as the heel of the wall, and this portion is known as the toe of the wall. Now, if we see the cantilever, the cross section of the cantilever wall, so we can clearly see that the weight of the backfill soil will also add into the stability of this retaining wall. A shear key is also provided to increase the sliding resistance of this retaining wall. Now, if we assume a linear distribution of the pressure beneath the base of the retaining wall, so we can see that we will have the maximum base pressure or bearing pressure, or the minimum bearing pressure, depending upon the eccentricity of the resultant load. If we see the cross section of the gabion wall, so it will look like somewhat like this, and the crib wall can look like this. Now, going into the details about the four modes of failure for rigid retaining walls. So there are four different modes of the rigid retaining walls. The first one is the sliding or translational failure, where the horizontal forces will move this retaining wall, and the retaining wall will slide from point A till point B, and that is the delta x, which is the change in the distance or the horizontal distance from point A to point B. So our focus would be to check the stability of the retaining walls using the sliding or translational failure, and this mode of failure will be discussed today. And rotation or overturning or bearing capacity failure will also be discussed in our today's lecture. There are other modes of failure for the rigid retaining walls. For example, if there is a slip plan is occurring, so this whole retaining wall will experience a deep-seated failure, and there is another mode of failure where the cracking will occur at this intersection between the base and the stem of the retaining wall, and that is known as the structural mode of failure in the retaining walls. Now, there are a few steps which are required in designing the gravity retaining walls. So the first step is that we need to find out all the horizontal components and vertical components of those forces, and also the resultant force which is acting on the retaining wall. For example, as we see here, we can clearly see that there is vertical component and horizontal component, or the horizontal forces and vertical forces are acting onto the retaining wall. So here we will sum up all the vertical forces, and we will also sum up the horizontal forces, and we will check the stability of these gravity walls. Now, minimum depth of 0.5 meter is recommended by different codes. Surcharge pressure on the is also recommended behind the wall of 10 kilopascal. Wall friction in the cantilever wall is the wall friction, or the delta, is 0, because here we can clearly see that this portion will be from the soil. So between soil to soil, that friction is known as friction angle. So delta is equal to 0 here. But when we talk about the wall friction between the retaining wall and the soil here, now delta won't be equal to 0 in this case. Now we will also find out the eccentricity, and we will discuss when we solve these problems, and it should not exceed b by 6, and we already discussed a little bit about that. Otherwise tension will occur in the soil. Okay, so what else we need to find out? We need to find out the maximum base pressure and the minimum base pressure, and then we can find out using P is equal to V by B, 1 plus minus 6E divided by B. Please kindly note down those equations, because we are going to use these equations in solving examples and problems in today's class. Now, if you want to find out the sliding resistance between the base and the soil, that we can find out using this equation, which is S is equal to V tangent delta, where S is the sliding resistance, V is the vertical forces which are acting onto the retaining walls, and delta is the wall friction, or the angle of friction between the base and the underlying soil. Now, in order to have the sliding limit state, the sliding resistance should be greater than or equal to the horizontal forces. Okay. Now, if the eccentricity is less than b by 6, then we can clearly see that we will experience the P maximum and the P minimum beneath the base of the retaining wall. And this will be assuming the linear distribution. So we can clearly see that the load is eccentric here with E. So therefore, P maximum would occur on the left side of this retaining wall. If E is equal to B by 6, then P maximum would be the maximum value and P minimum would be equal to 0. Now, if the eccentricity is greater than B by 6 and B is the width of the retaining wall, now in that case, there will be a tension which will be created on the right side of the retaining wall, and this will create the uplift of the retaining wall. Now we will solve two examples today, and we will understand that how we can find out and how we can design the retaining wall. Is visible. Wasim, can you hear me? Mohit, Hazrat Bilal,
Yes, sir, we
Tijaz
can hear you.
Ahmed.
Yes, sir, we can hear you.
Okay, so I need your help here in solving this problem. So here is a example. We are given with a retaining wall. This is the retaining wall. The height of this retaining wall is 5.40 meter, and the base thickness is 0.4 meter, and the width of this retaining wall is 3 meter. The width of the stem is 0.3 meter. Surcharge pressure of 10 kilopascal is applied here. Now the wall friction here is 0 because on both sides we will be having soil. Okay, what else? The width of this backfill material here is 1.75 meter. Delta is 27 degrees between the wall and the soil beneath the base of the retaining wall. Now the unit weight of this material, the concrete, is 23.5 kilonewton per cubic meter. What else we know? We know that the unit weight of the backfill is 17 kilonewton per cubic meter. C prime is 0, phi prime is 36 degrees, delta is 27 degrees, which we can find out using this equation, which is 0.75 phi prime. Now, the question is the design of the retaining wall satisfactory? So we need to find out two modes of failure. First of all is the overturning failure, and the second one is the sliding failure. Okay, so in order to do that, we need to first of all find out the forces which are acting onto the retaining wall, the horizontal forces and the vertical forces. Now in order to do that, what we can do here is we need to convert the surcharge pressure into the horizontal force. And if you remember from Geotech 2, it's taking a bit longer today. So if you remember here, if we want to find out the forces, so we can use this equation, which is Ka, which is the lateral earth pressure coefficient, Q, which is the surcharge pressure, and H is the height of the retaining wall. So using these equations, we can find out the horizontal force which is exerted by the surcharge pressure. Okay, so here we will find out now the surcharge pressure is 10 kilopascal. Now the height of this retaining wall is 5.40 meter. So what would be the value of the horizontal force which would be exerted by that surcharge pressure? The value of Ka, or the lateral earth pressure coefficient in active condition, because delta is 0 here, so it's better to use the Rankine lateral pressure coefficient Ka, which we can find out using this equation, 1 minus sine phi prime divided by 1 plus sine phi prime, or we can also use square of the tangent 45 minus phi prime divided by 2. So please note down this Ka value because we are going to use in solving this problem. Okay, now I need your help here. We need to build a table here to calculate forces and moments. Now, in order to find out the horizontal forces, and then we will find out the lever arm, and then we will find out the moments. So, for example, we will start with the horizontal force due to the surcharge pressure which is exerted on top of the retaining wall. So it will be K into H. So please kindly give me the value for this. This one here. So what would be the value? Is and as we know, the Ka value is 0.26 kilopascal.
सर आपका आवाज
5.40. Can you hear me?
सर आपकी आवाज कट रही है सर.
Okay. Let me change the internet to Ethereum again. Can you hear me now? Please confirm.
Yes sir.
Okay, that's good. Now, do you understand the problem?
सर जो आप स्टेप्स एक्सप्लेन कर रहे थे वो हमें उसकी आवाज नहीं आ रही थी जो आपने अभी स्टेप्स दिखाए.
अच्छा, चलें मैं दोबारा एक्सप्लेन कर. Look, here is the retaining wall, and these are the given parameters of the soil and the concrete. Now, in order to do that, first of all, we need to find out the horizontal forces and the vertical forces. Then we need to find out the lever arm, and then we need to find out the moments. In order to build or construct that table, then we will find the overturning mode of failure, and also, or we can say, the sliding limit state or overturning limit state. Now, if we want to find out the horizontal forces, so we will start with the horizontal forces due to the surcharge pressure. Now, from Geotech 2, we already know that we can find out the horizontal force if we use this equation, Ka into Q into H. So for this one, but we need Ka here, and Ka can be found out using the Rankine's lateral pressure theory, and for you it's 0.26. This Q, which is the surcharge, is 5.4 meter. So we will start with the surcharge pressure first, the horizontal force which is applied due to the surcharge pressure, and that's why we have written here Ka Q into H. So this would be the horizontal force which is exerted onto the retaining wall. So what's the value? Please kindly calculate that value.
2.04, sir.
14.04.
14.04. Okay. So that would be in kilonewton per meter. Now we also need to find out the horizontal force. We can find out this one if you remember. So the lever arm for this would be equal to, because it would be half of the height of the retaining wall. So what should be the value of the lever arm for this force first? Let me go there. Okay, it would be 2.70. And how about the moment arm? Sorry.
37.908, sir.
37.908.
908.
Okay, I would say 90. So it would be 37.9. Now, how about the second one? This
64.44.
So you remember this one is the lateral thrust, or the force which is exerted onto the retaining wall due to the rectangular distribution of the backfill material. Okay, Wasim, what's the value?
4.
Okay, 64.4. How about the lever arm for this
1.8.
1.8. So how we came up with 1.8? It's 1/3 from the base of the retaining wall. If anyone doesn't understand this one, so if you remember from Geotech 2, we know that it's acting, this lateral thrust P for the triangular distribution would be acted from the 1/3 from the base of this retaining wall. Now we already got this one. How about the moments?
115.9.
115.9. Now give me the summation of these two. I'll just add these two.
Say 153.8.
153.8. So these are the moments. These are the moments which are due to the horizontal forces, okay, onto the retaining wall. Now we also need to find out the vertical moments as well. But before finding the vertical, the moments due to the vertical forces, we need to find out the vertical force, the lever arm, and then we will move towards the moments. Okay, now if you want to find out, drag here so that you can see clearly. So this is the stem, the base, and the soil. So the vertical forces would be exerted onto the retaining wall due to the stem, base, and the soil. Let me show you here. So this is the stem, this is the base, the weight of the base, and also the weight of this soil would be acting downwards or vertically. So in order to find the values, I have simplified it for you people here, that we need to find out the height of the stem, the width of the stem, and the unit weight of the concrete. So please kindly give me the value for the weight of the stem here, or the vertical force which is exerted by the stem of the retaining wall.
28.2, sir.
405.
Okay. Please kindly repeat once again.
28.
What is the height of the
7.96. 0.4 plus 5.4, sir.
what is the so it would be, what is the height of the stem?
0.4.
What is the
Sir,
height
5
of this?
meters. Sir, 5 meters.
5 meter. That's great. Okay, now excellent. Now what is the width of the stem?
Point 3.
What's the width of the stem?
0.405 आता है, sir. 3.
Of the concrete, it's 23.5 is the unit weight of the concrete here. So I would say 5 into 0.3 into 23.5. Okay. So what would be the weight of the stem?
35.2.
35.25.
I would say here 3 kilonewton. Now give me the value for the lever arm. What would be the lever arm for stem? Lever arm for the stem. So if we take moments about O, okay, this is the toe of the retaining wall. What would be the moment arm?
Sir, 2.9.
So we need this 2.9 from the left side. Please check,
Sir, from the base.
because this is from the base. No, from left side. So pointing downwards. So we need this distance, or this is the lever arm in the horizontal direction, or I would say I will use this red color. So we need this distance. You need to subtract 1.75 and you need to add 0.15 because half here, so that will also go.
1.4, sir.
And then if you
1.4.
Sir, 0.1875.
You're getting it? This one, please give me this value here.
1.4, sir.
It's 1.10.
सर ये दरमियान में
This is the
माइनस
lever arm for the stem.
सही
Because yeah, this is, you need to subtract this because the whole width of the foundation is 3 meters. Now we need to find out the lever arm for the force which is exerted by the stem of this retaining wall. So we need to find out this distance. So if you see here, we need to subtract this one and we need to subtract the half of the stem, and this distance is 0.3 meter. Is it clear?
Sir, 0.95.
So if forces हैं उसको find करना है और moments due to vertical forces इसको हमने find करना है. ठीक है, मैंने थोड़ा सा zoom out किया है कि आपको थोड़ा सा clearly दिखाई दे दे. अभी तक हमने horizontal forces due to the surcharge, due to the backfill soil, lever arm हमने find किया और उससे हमने moments को find किया. तो हमारे पास moments due to the horizontal forces आ गई. ठीक है, अभी इस मूवमेंट्स की रीडिंग या वैल्यू मुझे प्लीज काइंडली आप दे दें, जो कि ड्यू टू दी स्टेम
38.7
38.7. ठीक है, 38.7. चलिए सही है. अच्छा, अभी हम बेस के लिए फाइंड करेंगे. नाउ फॉर बेस, व्हाट इज द हाइट, what is the width of the base, and the unit weight of the concrete. So the unit weight of the concrete will remain same.
28.2.
Okay, 28.2. Yeah, that's correct. How about the lever arm?
1.5.
It would be 1.5. Good. How about the moments?
42.3, sir.
42.3. Okay. Now, how about the soil, the backfill soil? The height of this
148.7.
148 point. Okay, okay. $148.7. And how about the lever arm?
Sir, I think 2.12, sir.
2.12. And how about the moments?
316.09.
316.09. I would say 1. Okay. Now you need to sum the vertical moments as well. So sum up those vertical moments, or the moments due to the vertical forces.
397.1, sir. $397.1, sir.
Okay, 397.1. Now we need to sum. Okay, we need to subtract the horizontal, the moments due to the horizontal forces and the from the moments due to the vertical forces. So if we sum those two moments, so what would be the summation of moment due to the vertical and horizontal forces. So we need to subtract 153.8 here.
Sir, 243.3.
243.3. Okay. Now note down this value, note down this value, and note down this value as well. Okay, how about the horizontal forces and the vertical forces? I need these two values as well.
78.48, sir.
78.4. And how about the vertical forces, summation of vertical forces?
212.2.
Okay, 212.2. So note down these values as well. Once we got
Sliding
all these, okay.
Sliding resistance.
Sliding resistance. Just wait a moment, please. Okay.
0.08.
Okay, just wait a moment. Now we need to find out the lever arm of the base resultant. Now we need to check if it's within the middle third of the base. For example, if this is the base, and as we know, this is 1 meter. Here is also 1 meter. Here we also have 1 meter. So total width of the base is 3 meter. So we need to check that the resultant is acting within the middle third, okay, of this retaining wall. So the summation of moments, what's the value of the sum? It was somewhat 243.3. And how about the vertical forces? The value of vertical forces was 212 point something 3. So we will come up with the value of 1.15 meter. And if you see here, it falls within the middle third of the base of the retaining wall. So that's okay. How about the eccentricity? And the factor of safety against overturning. So if you divide the moments due to the vertical forces and the moments which are occurring due to the horizontal forces, so you will get the factor of safety against overturning of that retaining wall. So what's the factor of safety for against the overturning?
$2.58.
2.58.
2.58.
2.58. Okay. 0.58. So that is greater than 1. It means that it's okay. Now, how about the eccentricity of the base reaction? So in order to find out the eccentricity of the base reaction, so you can use this equation, B by 2 minus lever arm of the resultant, which was 1.15 meter, and B by 2 is equal to 1.5 meter. So the value of eccentricity would be
0.35.
0.35 meter. And now you need to check that whether it's less than, so E is less than B by 6 or not. So if you see here, B by 6 is equal to 0.5. Now in that case, E is less than, which is 0.35 meter, is less than 0.5 meter. So that check is also okay. Now we will find out the maximum base pressure and the minimum base pressure. Now, in order to find out the maximum base pressure at the toe of the retaining wall and minimum base pressure at the heel of the retaining wall, so you can use the vertical forces and also the width of the retaining wall. The eccentricity value is also given, and the width of the retaining wall is also given. So please kindly give me the value for the maximum base pressure.
8.93, sir.
8.93. I think another value would be good. I need another value, please.
$120.
120. Yeah, that seems to be the right value. And how about the minimum base pressure?
21.22.
Now, what else we need to find out? We need to find out the factor of safety against sliding. Now, in order to find out the factor of safety against sliding, we will use the information of the vertical forces, delta, the wall friction, and the horizontal forces. So vertical forces were equal to 212.3 kilonewton per meter. Horizontal forces were 78.4 kilonewton per meter, and the delta value was, I guess it was 27 degrees. Yes.
1.37, sir.
1.37, which is greater than 1. So that check is also okay. Now, both the overturning check was okay, and the sliding resistance check is also okay. So now we can clearly say that is the design of the retaining wall is satisfactory. So you can comment that yes, the design of the retaining wall is satisfactory. So the first step here, I would just give you an overview again. We need to find out we need to calculate the forces and the moments here. Then we will find out the moments due to horizontal forces and the moments due to the vertical forces. We will sum the horizontal and vertical forces here, and then we will find out the lever arm of the base resultant, and after that we will find out the eccentricity and the factor of safety against the overturning using the MV, or the moments due to the vertical forces and moments occurring due to the horizontal forces. Once we find these values, we will find out the maximum base pressure and the minimum base pressure. Then we will find out the factor of safety against the sliding failure, and we can use this equation. It's a very important equation from quiz assignment and also the exam point of view. So the overturning check was okay, the sliding resistance failure mode check was also okay, so therefore we can comment that the design of this retaining wall will be satisfied. So that's one problem which we solve. There is another problem, and that is related to a sloping retaining wall and a sloping or inclined surface here. So this is another example, I would say problem number 2, related to the design of gravity retaining walls. Please note down these details: the unit weight of the wall, the unit weight of the backfill, shear strength parameter information, delta or the wall friction information. Now in this example, it is said that the P allowable, or the allowable bearing capacity, is equal to 250 kilopascal. Question is asked that is the design of the wall satisfactory? How we are going to solve this problem? Now, if you see here, the retaining wall is also inclined and the sloping surface is also inclined. How we are going to solve this problem? Now here we are going to use the Coulomb's lateral earth pressure coefficient, which is Ka. If you remember here, if the information of alpha, or the inclination of the gravity wall, is given, beta, which is the inclination angle of the surface with the horizontal, so please kindly use this equation and give me the value of the Ka, which we discussed in GeoTech 2 in the chapter of the retaining wall in the topic of lateral earth pressure using the Coulomb's theory. And just to give you a review, that for sloping ground or inclined retaining walls and incorporating the wall friction, we use the Coulomb lateral earth pressure theory. And if we ignore the delta, the wall friction, and if we ignore the sloping surface, or for the level surface, we prefer to use the Rankine's lateral earth pressure theory. please kindly give me the value of the lateral earth pressure coefficient in active condition. Hazrat Bilal. Fawad. Wasim.
सर कैलकुलेट कर रहा हूँ
Okay.
Point 698.
सर 0.696 0.696
Okay. 0. 696.
0.698.
I have a different value. I need another value, please.
Sir, 0.485.
0.485. So this might be the right answer here. So use Ka, the lateral earth pressure coefficient in active condition, 0.485. Note down that value. Then we will move towards finding the lateral thrust or the force which is exerted onto the retaining wall. And if you remember the lateral thrust or the force, we can find out using half Ka into gamma into square of h. So if you remember, this is the PA, which is the lateral thrust, which is exerted at 26 degrees from the horizontal, and from the normal, it would be 26 degrees. So use this equation where we have the value of Ka 0.48, and how about the unit weight? What's the unit weight of the soil?
Sir, 18.
18, okay. And the height of the retaining wall?
6 meters.
This is 6 meter. So give me this value, the lateral thrust or the force value.
311.04
11.02.
Sir, 155.5.
155.5 kilonewton per meter, okay?
55.52
Okay, that's right. 155.5 kilonewton per meter. Now that's the lateral force which would be exerted by the backfill material. Now we need to construct this table again, and how we can construct this table. Now I will give you a hint here that we can get the horizontal and vertical components from this lateral thrust. Now the horizontal force would be equal to PA cos 36 degrees, and this would be the vertical component of the resultant R. Okay, our R, I would call it PA. This is one thing which we need to do. The second thing we need to do to find out the vertical forces, this would be dividing the retaining wall in various components, in various shapes, so that we can find out the vertical force or the weight of the retaining wall. So that's how, please kindly take a picture of this screen, because we are going to use in constructing the table. So if it's done, then we will move towards constructing the table here. Now, what should be the value for PA cos 36 degrees?
125.81.
Okay, so let me take greenish color here. 120.
125.81.
Okay, 125.8. That's fine. So this would be the horizontal force. And how about the lever arm for that horizontal force? Lever arm for the horizontal force. What would be the lever arm for the horizontal force, or the horizontal component of the lateral thrust?
वो फ्लैश शो करे जिसमें वो क्वेश्चन के डाटा है.
Okay, I will show you that one. Yes, please. Recall Geotech 2, lecture number 2 in the, or part 2 of the retaining wall, related to Coulomb's lateral pressure theory. We made an assumption that the lateral pressure or the thrust would act 1/3 from the base of the retaining wall. So the lever arm for
2 meters.
it will be 2 meters, yes. This one would be 2 meters. Now give me the value of moment due to the horizontal force which is exerted onto the retaining wall.
251.62.
251.6, I would say that. Okay, now PA sine 36 degrees we will get the vertical component of the lateral earth thrust or lateral force. So the vertical component of the lateral thrust would be equal to
91.4.
91.3. And how about the lever arm for the vertical component? Let me show you this one. Taking the moments about the toe of the retaining wall, what would be the lever arm for the vertical component? Okay, let me give you a value here. It's 2.40, which is 2.75 minus 0.35. This will give us the 2.40. Now give me the moments.
Two 19.12.
219.2, I would say. Okay, how about the forces due to the weight of the retaining wall? And I told you to take a picture of this screen here, that this would be 1, 2, 3, and 4 parts. So if you divide this retaining wall in 4 parts, then we can easily find out the forces which are exerted. For example, let me draw here. It would be somewhere here. This one would be acting at the mid here. Now this one would be acting 1/3 here, and this one would be acting at the middle. Now you need to find out the lever arm for this force, then for this force, then for this one, and at the end you will find out the lever arm for 1, 2, 3, and 4. You need to do a little bit of calculation to find out the lever arms, and you need to take into account the 1/3 of the width of the retaining wall here, and from here you will add this distance plus the 2/3 of the rectangle. So you need to add from here till here, and then the mid portion, or maybe the fuller stem of the retaining wall, and then 1/3 of the width of the retaining wall. So you will get the lever arm for the first one, and if you add this 0.5 and into 0.5, and I don't remember the width of this section, so I guess 0.75. See, yeah, 0.75. So you can clearly see that we can calculate the values of the lever arm. Okay, now give me the values of forces and the lever arm and the moments. I need your help, please. Seventy. Okay, let me help you here. I have done the calculation here. It's half into 1.05 into 6 and into the 23.5. So this is the height and this is the width, okay? I would say wall because they haven't specified it.
Sir,
Yes, please.
Sir, 70.5.
Okay, 70. I have the value of 74. I don't know why. 74 here.
सर ये जो पोर्शंस है ना ये 1 मीटर है ना, जो 3 पोर्शंस है इसके बेस हमने 1 मीटर लिया इसलिए 70 ये आ रहा है सर।
नहीं यहाँ पे देखें ना, इसको थोड़ा सा वर्क करें। देखिए ये 1 मीटर तो नहीं है ना, ये हमारे पास, अच्छा पहले की तरफ जाते हैं। देखिए this portion is 0.5 meter, this portion is 0.5 meter, so from here till here it's 1 meter. Agree or not?
Yes, sir.
And from here till here we will be having 0.75 meter. Agree? Now we got 1.75 meter here and the total is 2.75 meter. So this portion would be 1 meter. Agree? Now you can find out the lever arm for this one. Now 1/3 of 1 meter. Okay. Let me check the data once again. 2.75. Okay, I have made a mistake here. It's 0.70. This one is 0.70 meter. So this one would be 0.70 meter. And this one would be equal to 1.05 meter. Okay, that slight change was occurring due to this error. Okay, anyways, that would be equal to now 74.0. Yeah, okay, so that was the error. The width was equal to 1.0 meter. Now, how about the second part? For the second part, we will be having,
98.7.
okay, I will write 6 into 0.7, and this is the unit weight. So 98.7. Okay, that's right. Now, how about the lever arm? First, we will calculate the forces and then we will go for the lever arm. Now, give me the value for the third portion of the gravity retaining wall. Okay, let me help you here. That would be equal to 5.25 into 0.5 into the unit weight of the wall. Now give me the value, please. That is 30.8. That's right. Now, for the fourth part of the retaining wall, you can simply find out the weight of that part by multiplying height and width. So, how much is the height? The height is 0.75. Please, the height info as well. That is 0.75 meter, and this portion is approximately, I guess, exactly 1 meter. So this is the height, and this is the,
17.6.
okay, yeah, let me note down here. So the height is 0.75 and the width is 1, and the unit weight is here 17.6. That would be 17.6 kilonewton per meter. Now, how about the lever arms for the part 1, part 2, and the part 3 of the gravity retaining wall?
2.05.
2.05.
1.35.
Here we are given with the 1.35.
0.83, sir.
0.83.
0.5 बनते हैं.
0.5. And how about the moments?
So the last part के 8.81.
8.81. Okay, last part is 8.81. And how about the third one?
25.56.
25.5. How about the second part of the retaining wall?
133.24.
Good, okay. How about the first one?
151.7.
151.7. Okay, just to make a correction, I have a value of 251 here instead of 257, so I would say 251.6 here. Okay, now the rest of the, okay, we go here, come up here. Now we need to find out the lever arm. Of base resultant, and that we can easily find out using the summation of moments divided by the vertical forces. Now the sum of moments was equal to okay, how about the moments due to the vertical forces and the summation of moments? Give me these two values, please.
Sir, MV 319.31.
Please check again.
Sir, 538.43.
538.53 kilonewton meter. Okay, this one will be kilonewton meter here. And summation of moments, we need to subtract the moments which are occurring due to the horizontal forces, and that's 251.6. Give me that value so we can write the sum of moments as well, which can be used to find out the lever arm for the base resultant.
286.85.
286.85, I would say 85. Okay, that's fine. Now note down this value, please. Note down this value, note down this one as well, and also the sum of horizontal. The sum of horizontal will be here. Now we need to sum the vertical as well. So 1, 2, 3, 4, and 5. So once you add all these values, you'll get the sum of vertical forces, and that should be equal to 312.6 somewhere, or 312. Note down this value as well, because we are going to use few equations for the overturning stability and the sliding resistance limit state. Now I need this value here.
0.91.
0.91 meter. Now MV and MH. So if we want to find out the overturning limit state or the overturning stability, so these are the restoring moments, and these are MH disturbing moment. So what's the value? Please kindly give me that value.
2.14.
Okay, so it's, okay, I would say 2.15, somewhere. So it's greater than 1. So the overturning limit state is okay or it's satisfied. Now, if you want to find out the eccentricity, for the resultant, how about the B by 2? So it would be somewhere here, minus 0.92. Please can you give me the value?
So 0.45.
0.45. Okay, and how about the pressures there, the P maximum base pressure and the minimum base pressure? Please remember that the allowable bearing capacity was 250 kilopascal. Okay, so we need to look for the value of the P maximum, which is the maximum base pressure. So it's very important. Please can you give me the value for the maximum base pressure and the minimum base pressure?
The maximum pressure is 226.53.
Okay, that's equal to 226. And the minimum I would give you that value is approximately 1 kilonewton per square meter equal to kPa. Okay, 1 kPa. So now we can clearly see that P maximum is less than the P allowable. So the bearing resistance limit state, or the sliding resistance limit state, is also satisfied. Sorry, the bearing limit state is satisfied. Okay. Now, in order to find out the sliding resistance, we can use the V tangent delta. Use V tangent delta So give me the value for the V tangent delta. It's the kind of restoring force.
152.46.
152.4 kilonewton, and the disturbing force is, what should be the disturbing force value?
125.81.
And that is equal to the H, which is 125.8, I would say, okay, kilonewton. So you can clearly see the restoring force value is greater than the H. So the restoring force value is greater than the disturbing force. So the sliding limit state would also be okay, or it would be satisfied. Now, final comments that overturning limit state is okay, and the bearing limit state is also okay. And how about the sliding limit state is also okay. Therefore, the design will be satisfactory. So that was all about the design of the gravity retaining walls. You can revisit those slides there. Where is the, oh my goodness, okay, I don't know where is that. So I will share the today's lecture after the class with you people. There are also a bit of theories given to get the and discuss the choice of the backfill material. As you already know, the ideal backfill material is the granular material, such as suitably the graded stone, gravel, or clean sand with a small percentage of fines. such a soil is free draining and of good durability. So you can see here that if we are constructing a retaining wall, so it's always preferable to have granular material here so that the dissipation of excess pore water pressure would occur and it will not exert significant amount of the hydrostatic forces which we discussed in GeoTech 2. Now, no matter what material we use as a backfill, its drainage is of great importance, and for designing of the retaining walls we need to keep that in our mind. Now there are different mechanisms which are used, different methods which are used to enhance the permeability of the soil and also to reduce the hydrostatic forces which are exerted onto the retaining wall. So gravel pockets are provided, granular backfill is also provided, filter materials are also provided at the heel of the wall. Here we can clearly see open jointed pipes can also be provided just to make it, no clogging should be done here. If it clogs, if it blocks, then the dissipation of that pore water pressure, excess pore water pressure won't occur, and that would significantly exert the hydrostatic forces onto the retaining wall. There are other methods available like filter strips. Vertical filter strips are also provided. If we are given with the semi-pervious backfill material, for example, if we are having higher amount of fine content which will reduce the permeability of those particles or those backfill material, now it's better than to provide the vertical filter strips midway between the weep holes. And you might have seen those weep holes filled with fine material, fine particles when you are traveling somewhere, and that will definitely cause significant increase in the hydrostatic forces, and that ultimately leads into the failure of the retaining walls. Now for clay backfill, continuous blankets or filters are provided so that it won't clog the weep holes and in order to facilitate the dissipation of excess pore water pressure. So different types of filter strips, blankets, continuous filter blankets can also be provided to enhance the dissipation of excess pore water pressure. Thank you very much for listening very patiently. Now we will move towards our question and answer session. Assalamu alaikum and Allah Hafiz.